People often say that building an X11 Window Manager is vastly easier than a Wayland compositor. Even the shilliest of Wayland shills are going to tell you that is the case. And it makes sense why. Xorg is a giant monolith of a codebase. It does a lot of things. Many you don't want and you don't need. However, it does a lot of things you do want and you do need. Meaning that if you just want to build a window manager, you don't have to worry about any of that lower level stuff like handling input and all of this complicated nonsense. On Wayland though, you don't have that luxury, at least you didn't. If you wanted to build a compositor, you would have to build it basically from scratch or from much smaller building blocks with a library like WL-Roots, Smithy, Mir. Each of these have different levels of abstraction, but they're all much lower level than what Xorg provides you. Now, people have suggested, hey, wouldn't it be nice to have something like this on Wayland? Something that does all of that lower level stuff you're going to do anyway, and then lets you, as the window manager developer, just focus on window managing logic. This idea has been shot down quite a number of times in the upstream Wayland repo, basically because nobody wants to do it, but the point of open source is, if you want it, you can just do it yourself. This is from the River project. This is a compositor that I frankly haven't messed around that much with. It's been around for a long time, probably a few years before Hyperland ever existed. It's a really cool project, and now, honestly, it's even cooler. Separating the Wayland compositor and window manager. Traditional Wayland compositors have a monolithic architecture that combines the compositor and the window manager into a single program. This has the downside of requiring Wayland window managers to do the significant work of implementing an entire Wayland compositor as well. So something like Hyperland, for example, it's not just a window manager. It does all of that lower level stuff as well. And then Sway has to do all of that lower level stuff as well. And River has to do all of that stuff as well. And Neri and all of these different projects, maybe they're sharing a library. You know, they might both be using WL-Roots or both be using Smithy. But besides that, there is a lot of repeated effort. The new 0.4.0 release of River, a non-monolithic Wayland compositor, breaks from this traditional architecture and splits the window manager into a separate program. There are already many window managers compatible with River. Over on this page here, I'll leave it linked down below, and this is super cool because you can actually build a window manager in a few hundred lines of code, and not some just like experimental, oh, it kinda sorta works, but because you're relying on something doing all of that like back-end stuff you would have done anyway, something actually usable. Also, if you do care, it is splitting out the AI sister stuff into a separate list, so if you just don't want to use any of that stuff, you don't have to. The stable River Window Management v1 protocol gives window managers full control over window position, key bindings, and all other window management policy, while River itself provides frame-perfect rendering, good performance, and all the low-level plumbing required. This is not for people who want to have full control over how every little thing is done, specifically what protocols they want to adopt, and all of these different things. This is for people that want to go and make some basic window manager, the thing that you could do on X11 that just was not a thing for this entire time on Wayland. And yeah, I guess you could have forked an existing project and then modified its windowing policy, and sure, I guess that was possible, but that was never intended with any other project, and they probably weren't documenting how to go about doing so. Here, this is the intention of what is being done. Now, let's talk about how it normally works. Traditionally, a Wayland compositor has 3 separate roles. Firstly, being a display server, routing input events from the kernel to Windows and give the kernel buffers to display. Secondly, a compositor. I really hate this naming scheme, the fact that we are using compositor and compositor to mean 2 entirely different things. Compositor on X11 is just this part. Compositor on Wayland is this part, and these other 2 as well. combine all buffers from visible windows into a single buffer to be displayed by the kernel. And 3, the window manager, arrange windows, define key bindings, and other user-facing behavior. The big reason why we have this system and we don't have something that is akin to Xorg on Wayland basically is because the X11 model wasn't great. It was designed at a time where you didn't have a personal computer. X11 is from the 80s. It is built around the idea of having the application and the server on 2 separate machines because you don't have the computing power to run the application together. And because of that, you got this architecture which, if you design today, would be considered absolutely insane. This does not make any sense whatsoever on a personal computer. It made sense in the past, but not now. Following the steps taken from a user clicking on a button in a window to the change in the Windows displayed content is quite informative. The user clicks on a button in a window. The kernel sends an input event to the display server. The display server decides which window to route the input event to. Already there is a problem here. Since the display server is not aware of the compositor's scene graph, it cannot be 100% sure which window is rendered under the user's mouse at the time. The display server makes its best guess and sends the event to a window. The window submits a new buffer to the display server. The display server passes the Windows new buffer onto the compositor. The compositor combines the Windows new buffer with the rest of the user's desktop and sends a new buffer to the display server, and the display server passes the compositor's new buffer to the kernel. With this architecture, the display server is acting as an unnecessary middleman between the kernel, X11 Windows, and compositor. This results in unnecessary round trips between the display server and compositor, adding latency to every frame. Honestly, the fact that it works as well as it does is a testament to how well it was designed at the time. It might be utterly insane, and you wouldn't design something like this if you started again from scratch. But it did last for a long, long time. The traditional Wayland architecture eliminates these unnecessary round trips and solves the input routing problem mentioned in step 2 by combining the display server and compositor into a single process, and now you get something considerably cleaner. Traditionally, Wayland compositors have taken on the role of the window manager as well, but this is not in fact a necessary step to solve the architectural problems with X11. Although, I do not know for sure why the original Wayland authors chose to combine the window manager and Wayland compositor. I assume it was simply the path of least resistance. I definitely think it is that, but also genuinely the fact that nobody developing Wayland wanted to take on the role of Xorg 2.0. Nobody wanted to be in a position where they had to make a compositor that 30 different projects were all reporting issues to, and all had different conflicting problems. So if you fixed one thing, it caused a problem over here. If you caused a problem over here, it might have done this thing, and then this thing, and then this thing. Because everybody was relying on this same really complicated dependency, and everyone wanted it to be slightly different. Not worrying about that, letting everyone go and do their own things, and then instead defining protocols made that job quite a bit simpler. Although it made the implementation considerably harder. The River Window Management v1 protocol is designed to give window managers maximum control without losing any of the key advantages of Wayland. Specifically, the window management protocol must not require a round trip every frame or every input event. There should be no input latency compared to the traditional monolithic Wayland architecture when, for example, typing into a terminal emulator or playing a game. Now, people will say, oh, but Wayland has a higher input latency. First, it depends on the implementation. Secondly, a lot of that does come from the forced vsync, and forced vsync is not really a thing nowadays. Vsync is nice, but it can be disabled in most things. I'm pretty sure River is one of those things. Furthermore, the Wayland ideal of frame perfection must be upheld. Again, River does provide the option to get rid of the frame perfection, but must be there as a default. To illustrate what frame perfection means in the context of window management, consider the following example. Several windows are in a tiled layout, taking up the entire display area, and a new window is opened. The window manager decides to add the new window to the tiled layout, resizing and rearranging the existing windows to make space. In this case, frame Frame perfection means that the user must not see a frame where there is a gap in the tiled layout or where windows are overlapping and have dimensions that do not cleanly fit with their neighbors. Achieving frame perfection here requires waiting to render the new state until all windows have submitted buffers with the newly requested dimensions. Note, the frame perfection is only achievable if the windows are drawn by well-implemented programs. If you write something that is bad, that takes forever to, render something, yeah, obviously, in that case, it can't be done, because otherwise what you're going to do is just freeze up the entire environment. So if something is taking too long, then you kind of do have to ignore it at that point. The protocol divides the state managed by the window manager into two disjoint categories: window management state and rendering state. Window management state influences the communication between the compositor and individual windows. It includes window dimensions, full screen state, keyboard focus, keyboard bindings, etc. Rendering state, on the other hand, only affects the rendered output of the compositor and does not influence communication between the compositor and individual windows. It includes the position and rendering order of windows, server-side decorations, window cropping, etc. I hate that you're making me look at a state machine diagram. I haven't looked at one of these in a long time. I hate looking at them, but this is basically how the actions, how the state flows around the system. As seen in the state machine above, the compositor initiates manage/render sequences, and no round trip with the window manager is required when no window management related state has changed. In other words, the window manager stays idle while the user is. For example, typing into a terminal and is woken up again when, for example, the user triggers a window manager key binding or a new window is opened. So basically, if nothing is being done, there's nothing new to render. So there's no reason to go and constantly prompt with something new. If nothing is happening, just use what you already had. At the same time, frame perfection is possible even with complex tiled layouts or server-side decorations rendered by the window manager. The compositor handles all the synchronization work with the windows, and the window manager only needs to, for example, adjust the positions of windows or size of its server-side decorations to adapt to the new window dimensions. This state machine is not really a new idea. Something similar can be found hiding inside most existing Wayland compositors, including River Classic and Swift, for example. In a way, this state machine is a clarification and formalization used by older River versions. It is the result of 6+ years of experience working on River and slowly refining the architecture over time. Now, the big question is why? Why do this and finally make this a thing after so many years of people being like, this would be a pretty cool idea? Separating the Wayland compositor and window manager greatly lowers the barrier to entry for writing a Wayland window manager. A lot of people talk about the problem of there not being that many floating options if you want to have a compositor. You can use GNOME, you can use KDE, you can use Cosmic, you can use the DEs, and then outside of the DEs, there's maybe 1 or 2 options, and everything else is either tiling or, like I'm using, scrolling or some other sort of model. If you want there to be more floating options and you didn't have the knowledge or weren't willing to go and dig deep into how to actually do so, this might be your chance to make that happen. Make something that is considerably easier to build. Window Manager authors can focus on window management policy without needing to implement an entire Wayland compositor as well. While libraries such as WL-Roots make writing compositor somewhat easier, it remains a great deal of work. Writing a Wayland compositor is not a weekend project. But with the new protocol, writing a basic but usable Wayland compositor over the weekend is now very possible. The Window Manager developer experience is also greatly improved. A Window Manager crash does not cause the Wayland session to be lost. So when everything is just the single one application, if that single one application crashes, it all goes down. Now, if your badly written Window Manager crashes, the compositor underneath the River part of it, that's probably gonna be fine. Window managers can be restarted and switch between. What this hopefully also means, I know a lot of people talk about this on X11, closing the window manager, but not losing your applications that are also open. Theoretically, that should be doable here. Debugging a window manager is much less an ordeal than debugging a Wayland compositor. Anyone who's written a Wayland compositor knows the pain of debugging issues that only reproduce when running on bare metal, i.e. using DRM or KMS directly. One might be forced to SSH in from a different computer to figure out what has gone wrong. Furthermore, window managers can be implemented in slow, high-level, garbage collected languages without sacrificing compositor performance or latency. Having a garbage collector in the compositor is a great way to miss frame deadlines and cause input latency spikes. However, since the protocol does not require a round trip with the window manager every frame, having a garbage collector in the window manager doesn't really matter. Yes, you are going to have some level of performance issues. He says it's fine with the ThinkPad X220, but if you write bad code's going to be bad code, right? Yeah, especially so if you have bad code with a garbage collector that is constantly being garbage collected. But it's a lot less of a concern when the stuff that is very latency heavy, latency low being required, when that stuff is separate from your code, which is terrible. Wayland currently does not come close to the diversity of X11 window managers. Whilst we often talk about things like i3, DWM, Awesome, BSPWM, there is 30 years of nonsense that is out there, some of which nobody uses anymore, some of which is really cool and really unique, and this right here is the thing that can very well change that for Wayland. There are some limitations, and you should have very well expected that for something which is trying to be a generic solution. The protocol does not support use cases that deviate from the traditional 2D desktop paradigm. This means no VR support. If you thought that was going to be there, look, I don't know what to I do not know what to tell you. But if you want to do a tiler, if you want to do something like Hevel where it's a scroller but it has like vertical scrolling as well, if you want to do Niri, things like that should very well be doable. Crazy visual effects like wobbly windows are also out of scope for River currently. Though, simple animations already work well, and I am open to exploring custom shaders to give window managers more control over rendering eventually, but don't expect that to happen for a year or two at the earliest. There are other priorities now. With custom shaders, you could do basically anything you want. If you want to have burning windows, if you want to, like, I don't know, you could do a cube with custom shaders, should you? No, but you could do so. I am not aware of any limitations River places on window management policy that cannot be resolved by extending the protocol, and as such, if you would like to do so and get involved, either report an issue or, you know, help out with the project in some other way. Honestly, I think this is super cool. Now, I am happy on Niri. I'm going to keep using Niri for a while. Maybe I'll try out something else, but, you know, once you go scrolling, it's really hard to try something else. Is there anything that is scrolling right? Yes, there is. You know what? Okay, maybe I will have to give it a try then, at the very least. But if there's something that you want that maybe is missing, maybe you want some, like, specific customization system, you want some, like, weird system nobody else thought of, now there is a position for you to very easily go and do so. So check it out, give it a try, go support the project, and build things. Build something cool. So let me know your thoughts. Do you think this is cool? Is there something you would like to see out there that just doesn't exist yet? Or are you going to build something yourself? I'd love to know. So, let me know your thoughts down below. Like the video, go subscribe as well. And if you really like the video and you want to become one of these amazing people over here, check out the Patreon, subscribe to Sally Barrett Pay, linked in the description down below. That's going to be it for me, and let the window managers flow like a river.
Something like this.